Hi, my name is Shawna Watkins, and behind the camera is Sandy Samuel. We are on Dr. Bidlack's gene transfer team, and we are going to show you guys how to do Touchdown PCR today.
So first what we're going to do is we're going to get a bucket of ice, preferably something that's insulated but doesn't have to be. And you get that from the ice machine, which is right there in the lab. So next what you want to do is you want to label one microcentrifuge tube for each strain that you're going to use. So we're just going to show you one strain, and obviously you'll repeat that for all the 5 strains that you're using. Then you want to label one tube MM, M as in Mary, M as in Mary, for master mix. Another one buffer, and you can label that as BUFF. Another one as TAC for TAC polymerase, TAQ. And lastly, one for the TE buffer with the DNA. So next what we want to do is we want to prepare the tube for one tube for DNA extraction. And so what you want to do is you flame the lip of the TE buffer solution 3 times. You always want to work aseptically, and so that's very important. And you want to add 100 microliters of that TE buffer to a microcentrifuge tube, the one that's labeled TE buffer. Okay. Then you want to take one colony and put that into that solution. So for that you get in an inoculation loop. Make sure to work aseptically as well. Do not touch the end of the loop that you are scraping the plate with. And you want to get an isolated colony. You want to scrape the plate and put that in your solution of TE buffer.
Next, what we're going to do is we're going to make a 1X buffer, and we're going to add 45 microliters of DI water, which is distilled water. And you can get that at the sink and with the faucet that has the white water. It's very important that you use that water.
And we're going to add 45 microliters of that and put it into the tube labeled buffer, or BUFF. Then you want to add 5 microliters of the 10X buffer with no magnesium into that microcentrifuge tube as well. Next, we're going to make the 1/10 TAC buffer. And to do that, you're going to combine 45 microliters of the 1X buffer that you just made. And you want to add 5 microliters of the TAC polymerase from the TAC PCR kit, which is right there, and it will be in the freezer. Into your TAC microcentrifuge tube. Next, what we're going to do is we're going to make a master mix. And we're going to put all of these ingredients into the master mix microcentrifuge tube. So you're going to get 88 microliters of magnesium chloride, which is also found in the TAC PCR kit. And again, all this goes into your master mix. Microcentrifuge tube. Then you're going to add 44 microliters of the distilled water that you got from the sink. And you're going to add 27.5 microliters of the 10x buffer. As well as 27.5 microliters of the DNTP, which is also found in the TAC PCR kit. And then you're going to get 27.5 microliters of the 1/10 TAC polymerase that we just made earlier. And put that into the master mix microcentrifuge tube as well. And lastly, we're going to take 16.5 microliters of the YCIFI and YCIRO. Which are the DNA primers that you will find in this box in the refrigerator. That cannot go in the freezer, so make sure you put that back in the refrigerator only. And you get 16.5 microliters of both of those DNA primers and add that to your master mix. And that concludes the master mix step of the process. The next step is you're going to take 45 microliters of the master mix that you just made and put it into each PCR tube that you are running through the PCR cycle, as well as 5 microliters of the DNA that you put into the T buffer tube earlier. And putting into that PCR tube that you will be running it through the PCR cycle. Okay, and so to run the PCR, you're going to come to this machine, which is the PCR Sprint thermal cycler, and you want to hit run, you want to hit enter. You want to go down to Touchdown PCR, hit enter to continue, hit enter again. You are using microcentrifuge tube, so you'd enter, and then you put the PCR tube in, close the lid, and start the process, and that is how you do PCR.